Well, I'm still not happy with the results of looking at this power supply from the last 2 videos. So I want to look at it again. I'm making no promises. There are a few things that I meant to do before that I didn't get around to doing it. And there were some really good comments in the past few videos. So let's give it one more try. Why not? I'm going to do this anyway, so I'm just turning on the camera. Maybe we'll all learn something along the way. So first things first, notice this time I brought the monitor over because one of the things that I was not happy that I did last time is I did not bring the monitor over because it's kind of a pain. I need to bring the monitor. I need to bring the power transformer because it's a 220 volt PAL system. So one of the things that I did last video is I was turning on the PAL Commodore 64 and I was never seeing if it was really starting up correctly or not with the full 1 volt drop. So that is one of the things I want to remedy today. And then I just want to look more closely at the power supply. And here's the thing. I was always making an assumption that these 2 modules were independent, so that this was generating the 5 volt DC and this was generating the 9 to 11 volt AC. But you know, part of the reason I was confused about this is like the 2 amp 5 volt. So maybe this uses the 5 volt as an input to generate 9 volt AC. And so I was dismissing the 9 volt AC area of the board here. But if that is causing the extra current draw, it could cause that current draw from here, and it could cause this one to shut off, which then means we see the 5 volts shut off on the computer. So I want to isolate those things and look into that a little bit more. So that's kind of the plan for today, and then we'll see where things lead us in the next hour or so. First things first, because I know how these things go, let's make sure it works. I can't tell you how many times I've taken a project, I started doing things, and like, it was not working, and it turns out it was not working from the beginning. So I've learned my lesson. So I have everything plugged in, and okay, we got LED there, and do we have? By the way, I'm recording this in 60 frames per second because what shows up in here is not that important. We just want to see if we get the basic prompt or not. So excuse the flickering. That will hopefully happen. We get an LED there, and okay, we get this, and we probably get the rolling. Yep, okay. But you can see that it's the basic prompt. Things are working. Cool. What if I turn it in a couple of times? Will it do? Yeah. I mean, it would be good to get to the point that this happens pretty repeatedly. And this is what I've noticed other times, that at the beginning, it seems to work mostly okay. And it's after a little while that then I start not getting voltage from the power supply. So this seems to be fine. I don't know if it's a matter of leaving it on for a while and then back on and off, but it certainly doesn't seem to happen right at the beginning. It seems to happen more later. So that could also be a hint of what's going on. Unfortunately, I can't just leave it on while we look at the power supply. So I'll turn it a couple more times. It's also disconcerting that the Commodore takes so long to bring up the basic prompt. I mean, it's surprising. I don't know why they wait so long. I know there's a special circuit, there's a 555 timer for the reset line. And I mean, that's what, like that's a full second or 2. And I know that's normal. I just don't know why so long. One of the things I like about other computers are they're instant on, like the Amstrad. Actually, most of them, the Spectrum, Auric, Dragon. I mean, actually no, Dragon takes a while. Dragon takes also a little bit. Yeah, but I don't know why they chose to delay that so much. So this seems to be working fine, which is not ideal for us because we want to get to the point that it's starting to fail again. Anyway, let's put that aside for a second and let's look at the back of this, see if we get some hints. So I've just turned it off, unplug it completely, and then plug it from there. And this has been dangling, but this is the switch. So if I remove this, I mean, it's fine for testing, but if I remove this, I imagine we will never get any current because this will be a closed switch right now. And so we have hot glue and screws. So maybe the hot glue is just for extra security. And we seem to have 3 screws in there. I'm not sure whether hot glue helps if we have those in there. Wow, that's can you see in the camera how bent this PCB is? Yeah, like that. It's a little scary. Okay, let's remove that and open it up. I mean, yeah, you know, I can just heat it up, but I may have to. I mean, they put a lot of it here. It's also surprising how close to this module the screws are. It almost feels like it was designed for a smaller module here, and this is a slightly larger one than they were expecting. Oh, really? This is not everything? I mean, I know they have some in there, but I didn't think that was going to be holding it. Okay, so yeah, it was just held together by that. Right, so we still have the 2 cables going to the input. I'm going to leave those alone. I wonder what this is. I mean, this is the form factor of some kind of power transistor, but it has one of the legs is missing, and it looks like it was never even soldered in. This is masked. So, yeah, I don't know what that is. And yeah, there's a little bit more functionality built into the board than I expected when I first saw the 2 modules. So hopefully that is taking care of some of that protection. Let's just map this a little bit. I need to bring up the pan of ice again. Some of you were asking me about this one. I have all the tools linked in the main channels page. You should link from quite a few there. Also, if you go to noelsretrolab.com, there's a tools page. And you can see most, if not all, of the tools that I use, and they have affiliate links to Amazon. So if you buy something through there, then I get a tiny little bit of kickback, which is great. So it's probably not, but so I know this one is ground, and I'm curious if it's linked to the shield ground, and no, it's not. Okay. So this ground, which of those 3 is it? 4. Okay, that's ground. And is that 5 volts? Yes. Okay, so we have ground, 5 volts, and then those 2 are the AC ones. Okay, so knowing that, and you know, this might not work because it may be filtered through something else, but if this is the 5 volt output, is it? Oh, it's coming straight from that module. That's probably ground. Yep, because he beeped once. Yep. So is that 5 volt being fed to that other one? And the answer is not directly. I'm not too surprised. And are the inputs? I'm trying to see if the current goes directly into there, and I'm seeing why am I only getting one of them, but not the other? Well, because the other one is going to the switch, and so the switch is here, right? So I should be checking this. There we go. So, yeah, my theory doesn't seem to be correct. It looks like this is what I thought at the beginning, and this seems to have an input of the AC current directly here. And this one does as well. The 5 volt one has this one and this one. Yeah, so they both get the input from the AC current directly. Now, maybe this is still connected here somewhere, so I'm still curious about the 5 volt. I couldn't find much information about this. I wonder if some of that is some wiring for 220 versus 120 volt AC input, maybe. Oh, you know what? It says US right there. That's probably exactly that. EU, yeah. I didn't even see that. That makes sense. So they can have jumpers and connect to one place or another. Okay, well, that seems to make sense. So yeah, the theory that something happening in the 9 volt AC is affecting the 5 volts is pretty unlikely, but there's still a few things I want to try. Just going to put it back. Now, I wonder if I'm going to find out the real reason. Oh, I wonder if the real reason they have, oh, I think I'm seeing the real reason they have the screws. Look how little material there is in that PCB. Maybe they either thought or they shipped it without that hot glue, and in shipping, the PCB broke with a lot of jostling and stuff. And that was a cheap way to make their PCBs work. And you can tell it's really cramped. I mean, this is really big, and I mean, the PCB could definitely be a little wider. And maybe in later revisions they made it, I don't know, just like 3 millimeters wider in each side, and it would fit still in there, and they wouldn't need that. I bet you newer versions of this board have that, because yeah, this is totally sturdy, and I still don't like that angle. And I doubt there is anything breaking, but it's just yeah, I don't know. It probably doesn't matter. I just look at it and I go, I don't like it too much. But it's funny, they even have hot glue in here. But I mean, so short story from experience. Many years ago, the way I started, before I was making videos and all those things, one of my hobbies was repairing retro computers. And I was doing that in Spain, and so it got to a point that just repairing them was fun, so I would buy them, specifically ones that were not working, and then I would just sell them back out. And so for a few years, I was shipping a lot of computers. I was shipping, I don't know, I was probably like shipping 2-3 computers a week. And it got to the point, like, out of 50 computers that I shipped, 49 would be fine, but one would get there and they would get back to me like, hey, it's not working, which is devastating, right? And then I was able to work with some of them. I had to accept some returns. And what I saw is that certain computers had a habit of failing the same way after shipping. So specifically, I remember the ZX Spectrum Plus 2, I think it was the gray one specifically, has, God, I don't remember what it is. It has a connector very similar to this. Maybe it's the power connector. There's an internal power connector, very similar to this. And every so often, just in shipping, it would pop open. So yeah, the person would get it, turn it on, and nothing was working. It's like, hey, what is this? This was supposed to be working. So this is, I mean, I ended up doing something similar to this. It was enough that I ended up putting some, I think it was just putting some masking tape, or like, okay, you're not moving in shipping with all the shaking around. So this is probably similar. There's probably no need for this, but they probably figured out that by shipping this enough times, some of those cables will come out during shipping. So yeah, that makes sense. Okay, that's not good. We don't have a light. What happened here? So I must have accidentally knocked out the LED when I did this. I know I bumped it a couple times, but yeah, we're getting power. We can turn it off from the switch. Okay. All right, not a big deal. All right, got some tea, so much better now. Anyway, I think the next thing I want to do is what I mentioned earlier, confirm to see if the commutator really was turning on completely with that extra resistor added. And then I want to change the resistor to something more appropriate. So first, just let's see if it works. Okay, with this, the adapter there. Aha, okay, so I'm not surprised at all. So this is, we saw last time that this was running, instead of the 5 volt rail being full 5 volts, is like 4-ish, and that is obviously too little. Okay, not surprised at all. I honestly don't think that would have influenced the power supply staying low all the time or not, just that little 1 second that we were seeing, but it's good to know. So, since last week, I went ahead and bought some more appropriate resistors. I just didn't have those things. So, I got these. These are, I think they're like cement or something, but they're actually 0.1 ohms, and they're rated for 10 watts. So, we accomplished two things. A lower voltage drop than that, which is what we want, and is going to be able to deal with all the current going through here without overheating and exploding or setting on fire or getting very hot like that one was doing. So I'm gonna go ahead and solder this in place and we'll test it again. All right, and there it is. Again, not winning any prizes from soldering job, but that is not the point. The point is doing something quick and easy so we can test things. Okay, we're connected. Let's try this. Before I even measure the voltages, I'm curious to see if that starts up. There we go. Okay, so that confirms what we expected, and I'm sure if I check the voltage here, it would be pretty close to 5 volts. Yeah, 4.92. Yeah, that's why we're using a 0.1 ohms. You know, originally, looking back, it sounds ridiculous, but I think my first pick for this was 10 ohms. And I wasn't thinking that, of course, we are drawing almost 1 amp, so that makes sense. That was way too much. I was going more based on the resistance. I was trying to choose a small fraction of the resistance between the VCC line and ground on the commutator. But yeah, I should have thought about it. Like, it's going to draw a constant amount of current, so 0.1 ohms makes much more sense. Okay, so with that in there, let's do the oscilloscope measuring again, and now we'll be able to maybe make better measurements and zoom in a little bit more and maybe see if we see that spike. Although, honestly, I'm not sure what we're going to be able to do because this is just not happening today. I'm turning it on, and it is working every single time. Hasn't failed a single time yet. This is the worst kind of repair, when you can't reproduce it. I don't know, maybe it will start happening as we keep messing with it. Okay, so actually I see that I still have it set up from last time. So, and right, it's reading 5 volts because again, this is before the input and I didn't turn it off on the power strip as I should have, but that's okay, I think. The difference is showing up as 0, and obviously, because there's no current flowing through. And when I turn it on now, you barely see any change in there. So I need to change the scale of the difference. So math menu, scale, Okay. And we're going to zoom in some more. And we may have to set up a trigger. I mean, it's unfortunate that there is that much noise. I don't know if that's the long leads or something. Let's see what happens. Oh. So there was definitely a little spike. Now, we have to remember, these are 200, we're in 200 millivolt each division, so that was still half a volt. It's a fair amount of current going through there. Yeah, and you can see there is a, oh, there we go. We managed to get that to happen, that delay. Interesting that it starts just now. There we go. Can I set up a trigger? I don't think I can set up a trigger on the math result, unfortunately. I could set up a trigger, sure. A fallen trigger on C1. Okay, I'm gonna set a trigger pretty low, like that. And now I need to go back to the math menu and change the scale. There we go. That was not a huge drop. Let's do it again. And it didn't trigger. So yeah, this is interesting. Not a huge spike, and we didn't get that temporary low. Same thing. I really want to try to catch it. That was a little bigger, that spike. No luck, no. But we got it multiple times in a row. But now we're looking at, this is Heisenberg repairs. Once you look at it, they stop working, or they stop failing. There we go. Now we got it. And I'm not seeing any big spikes in here. You would think we would see something. Unfortunately, if I zoom in here, I think the data disappears. No, okay. So there was definitely no spike that I could register that caused that drop in there, or even at any time afterwards. There were no spikes this time at all. How interesting. So much for my theory of a transient current triggering the fault protection in there. And now that we have here, is this exactly 1 second? 1, 2, 3, 4, 5, 6, no, 6.5, and 80 milliseconds. It's exactly half a second. Well, maybe that's a little bit more than the remaining 20 or so, but it's almost half a second. So here's when we see the spike. There's definitely a spike in there. Yeah, look at that. We got, so, I mean, it's a relative spike. So we are doing 200 millivolts for almost 600, let's say 600. 600 millivolt drop across 0.1 ohm. Is that 5 amps? No, that can't be. Supposedly, I mean, clearly those measurements are not very accurate and all that, but that's a big current. That seems like a little spike of 4 or 5 amps. Which, if I saw that, I could see that that's enough to trigger something, although maybe that's normal in a startup. I know a lot of things like motors and things have huge draws on purpose at startup. This is inconsistent, and I've never examined other commuters at this level, so I don't know if this is normal or not. I don't know if they're filling capacitors that are doing that, or all of them do that semi-randomly, and maybe there's like measuring issues, so sometimes we detect the spike and sometimes we don't, so there's a lot of uncertainty here. This exploration, let's call it that way. And another, and now it's a bunch of spikes, and still the voltage is not dropping. That is really interesting, the shapes we're getting there. You know, one spike, another spike, another spike, and obviously the voltage drops every time. I mean, that made, this is not scaled, I mean, it's scaled by 1, so that made the overall voltage drop to a bunch. And this spike is even bigger. Wow. Yeah, so that seems like a lot of current, even if it's a tiny fraction. So I'm wondering if I'm maybe not measuring something correctly, or there's some limitations on the resolution of this. But that is very interesting. As I said, I've never done this kind of deep measurement like this before. And as I would expect, the resistor is not warm at all. Wow. It gets worse. I mean, what is that? And I even saw another one. I mean, what is going on in there? This is getting worse as I'm running it. And now it's not shutting down at all, which is really bizarre. I mean, this is getting kind of crazy. Yeah, look at that. So the next thing I wanted to try, because I'm not sure what else I can learn from this, the next thing I wanted to try was to test, can the 9-volt AC be affecting the somehow the voltage draw and the power supply stalling and all of that. So as far as I know, this should work the same way. It's just that some, oh wait, without 9-volt AC, we're not going to be generating the voltage for the SID, which is not a big deal for accessories, but we're also not going to be generating the voltage for the VIC-2 chip. So we're not going to see anything here. Still, we're going to see if we get any those same weird voltage drops. And the answer is yes. We get them just the same, and as I expected, we get nothing on the video. Okay, that makes sense. Those are even crazier voltages. I know what I'm going to do. This is something that just occurred to me. I'm going to hook up an original Commodore 64 power supply to this, and let's see what happens. But I'm also going to solder this because I like seeing the image. Okay, using the new power supply. Okay, so that kind of weird current draw seems to be normal for this board. Now it would be very interesting to try a different Commodore and see if that happens. Let's do it. Okay, this is one of the Commodores that we saw in a couple of videos ago. This one that was working and maybe had the fuzzy. Okay, so yeah, this part is just working with the bad image quality. So this is perfect. Obviously it's a different revision, but we should be able to see whether it does something more or less the same or just something completely different. And this is NTSC, so it's not hooked up to this TV. That's fine, that's not the point. The point is, what are we gonna get here? Okay, we're getting more or less the same kind of weird behavior. Yep. Okay. So this is good. I'm definitely learning what the normal current draw behavior thing for Commodores is. That seems, even though it's a very different board revision, it's an NTSC board, it's the same kind of ugly, spiky thing that we're getting in the other one. Now, whether some of that is exaggerated by some of my measuring techniques, it's possible. Some of you professionals with a lot of knowledge about oscilloscope, tell me please if there's a better way to measure this. I mean, I have to make the 4th video about this, but that's okay because I'm learning. I think some of you are learning some of that things along the way, so hopefully it's useful. But yeah, this is definitely very, very interesting to me. We're thinking, could it be bad capacitors? Well, if so, this has the same problem, which is possible. It's an older board, but the fact that they're both identical makes me think that it's not that. Okay, so one of the things that a lot of you suggested, and one of the things that I checked from the beginning, is could the switch be faulty? The switches on the Commodore 64s are notorious for failing, so I've had plenty of those. I've also had problems with the socket, the power socket itself, with cold joints underneath breaking and all that. So that is one of the reasons in the very first video I measured voltages and there was just perfect continuity. But some of you said that maybe even with that continuity, there could be something that when you turn it on, it could do something weird initially, and then you get perfect continuity or something. So let's have a look at that. Delicious tea, by the way. I'd rather not disassemble this completely right now because mostly I would have to desolder those 6 parts and I would have to unscrew everything. So that would be the correct way of cleaning that switch, taking it out apart completely, removing the plates and cleaning the inside. I think as a first pass, we can just apply some contact cleaner. Let's see if we manage to get the voltage to drop like it did. Although again, because it's not reliable, it's very difficult. If it doesn't happen right away, is it because of this, the cleaning, or is it because it just doesn't want to do it? But if it happens again, then it's probably not the switch. Okay, so we have everything. Let's set up the trigger again. And wow, first hit, we get that voltage drop holding for 1 second, or is that longer now? Yeah, 400 milliseconds, it shouldn't be. That zoomed in. Oh, interesting. Wow, that happened for a while. So we get all these weird things. Whoa, okay, let's look at this. What happened here? There isn't a lot of current, wait, but when I turned off the oscilloscope, did that just change the scale? Oh, yes, the math is up to 2 volts. Wow. So, wow, what happened here? So we got some huge spikes of voltage. Up. And then negative voltage? And then after we get even worse, well, the spikes in current are not as much in there, but huge spikes in voltage, then it definitely drops out for a while. So it definitely doesn't seem to be related at all to the switch. But that was some nasty things that it did in there. So I'm going to turn off the math and the second channel. And I'm just going to measure this in the 5 volt rail. Are we really getting those weird, those horrible spikes? I mean, that's incomplete. Wow. Yeah, I mean, this is big spike followed by dropping in. But at least the spikes I'm seeing there are not as ridiculous as what we were seeing earlier. And that's 2 volts. That's going, it's not going very high. But maybe I need to zoom in more. That is some ugly voltage shapes. But that's the kind of crazy thing that we're seeing in the other one. So yeah, I mean, that could be capacitors charging. And because we're so zoomed in, it doesn't mean that it's not shut enough further along. So yeah, that was an interesting exploration. We haven't really solved much. I've learned quite a few things though. I've learned that there's those weird spikes on voltage and current at startup, which is relatively to be expected, but it's good to confirm that this Commodore 64 and some of the other ones behave the same way. That it happens with the linear original power supply. And we really haven't seen any correlation of why this particular power supply decides to throttle down voltage sometimes, and we actually haven't even seen it do it constantly. The most I've got it was the half a second delay. So, well, that's what happens with this kind of videos. Unexplored and unscripted. You never know where you're going to end up. So anyway, I learned a few things. I hope you enjoyed it too. If so, thanks for stopping by, and I'll see you next time.